Hey you guys, this is Mr. Sal. We're going to go over Module 5, Section 5 here. Applications of adding and subtracting fractions, which of course is going to include some mixed numbers. Now don't forget, even with this video, if you guys need to pause, I recommend pausing before we do the problem. We're going to go over them. But before we do, look at the problem, pause it, try it out, do it on paper, do it at home, and then start playing the video so you can see how we're doing it. You're going to learn a lot more that way than if you just watch the video and try to learn by me doing it all the time. So I'm going to start with this problem. An electrician has a wire that is 3 2/3 yard long. She cuts off a piece that is 5/6 yard long. How much wire is left? Now, we know the two fractions we're dealing with were the mixed numbers 3 2/3. And then we're dealing with the 5/6 right there. Well, what's the relationship between these two? Well, it said that she cut off a piece that is this long. So what operation would that be? Well, hopefully we know that cutting it off means we're going to be subtracting that much off of the wire that we had. So I'm going to use the method where we're going to change this into a mixed number. This mixed number into an improper fraction first. And that would be 3 times 3, which is 9. And then add the 2 up there to make this 11/3. And yeah, I'm subtracting my 5/6 right there. I don't have common denominators, which I do need. So I'm going to change 11/3 into sixths by multiplying it by 2, which would then give me 22/3. I'm sorry, sixths. And subtract my 5/6. And I know that 22 minus 5 would be 17/6. I just need to change this. Well, I guess it didn't say. It did not say to change this into a mixed number, so I'm just going to keep it at that. But just remember, if you're going to keep it at 17/6, you will lose a point on the test. This needs to be changed into the units, which in this case was yards. So don't forget to label your answers. 17/6 yards is okay. If you're like, Mr. Sal, I don't feel comfortable until I see the mixed number on this thing, so be it. It should have been 2 5/6. But again, don't forget to label your answer in yards. Alright, here's our next example. A flight from Salt Lake City to St. Louis, Missouri requires 2 5/6 of an hour. If the plane has been flying 1 1/4 of an hour, how much more time, find how much time remains before landing. So again, I like a diagram on this, okay, because it kind of shows what's happening. So first we're going to start with Salt Lake City, and then over here we got St. Louis. And we know that the distance here, it's not really distance, but the time for this flight is going to be a full 2 5/6 hours, right? Now, what we have here is the plane, and yes, this circle is going to be the plane. It starts at Salt Lake City, and so far it's gone 1 hour and a quarter of an hour, right? So the question says, find how much time remains before landing. Well, that would be the distance from where the plane is to St. Louis. This would be how much remains. So the diagram hopefully helps us to see what is happening between these two values. I know that how much it's, or how many hours it's been in the air, plus how much it remains, needs to be the total amount of time in the air. Which means that if I want how much remains, I'm going to have to subtract the 1 1/4 hour from the 2 5/6. In other words, you had 2 5/6 hours when you started, and we're going to take away 1 1/4 hours that it's been in the air, And that should tell us how much time is going to remain on this flight. Now I'm going to use method 2 for subtracting mixed numbers. But before I do, and I probably should have showed this in the last video, in the last section or lesson for this unit, but I can change the denominators to be the same right now. Now it's not going to change the whole numbers. Okay, I still got 2 and something minus 1 and something, alright? But I'm going to show that I can change these right now. I'm going to change 5/6 common denominators. I'm going to use 12. So I'm going to multiply 6 and 5 by 2. So 2 and 5/6 is the same as 2 and 10/12. And we'll be subtracting 1. So I got to make that 1/4 into 12ths as well, because I do want common denominators. And to do that, I'll have to multiply these by 3. So I got 2 and 10/12 minus 1 and 3/12. And again, why did I do that? I did it to make it easier with the method 2. I got 2 minus 1, which is 1. And then over here, I got 10/12 minus 3/12, which in 12ths would be 10 minus 3, which is 7. So I got 1 and 7/12. And that was really good, right? It was like, wow, we did that problem. We nailed it. We did a lot of work. We even showed a diagram, and I'm feeling really good about that thing. I even boxed it in, right? But don't box it in, because it's a word problem, you guys, until you can box it in after you label it. And this one happens to be in hours. So don't forget that part. Make sure you label it. And everything will be good on those tests, okay? Alright. I think I may do this one twice, alright? So we'll use the classic way, but let's read it first. Make sure you read these before you go over them, alright? A pair of jeans is 32.5 inches long. How long are the jeans after they have been washed if they shrink 1 2/3 inches? Now shrinking on this one indicates that we're gonna start with the original length of the jeans, 32.5, right? Shrinkage would indicate subtraction, and how much are we subtracting? Well, 1 2/3 inches. Both these are the same units, so we're not worried about conversions, and we shouldn't have to right now in this specific class. Now, before I proceed, well, actually, I'll use this first method, right? So I'm going to change these both into improper fractions. So I have 32 times 2, which is 64. And then I got to add the 1, which makes this 65 halves. And then over here I got 1 times 3, which is 3. And then add the 2 there would make that 5/3. And yes, this is in subtraction. We are subtracting fractions, but they do not have like denominators. So I'm going to use 6 as my common denominator, which means I'd have 3 times 2 in both cases, but the numerators be multiplied by the same thing the denominators are. So 3 times 65 is 195 in sixths, and I would be subtracting 5 times 2, that's going to be 10/6, which after the subtraction would give us 185 sixths. Now again, the last thing I would do on this is just to see if these could be simplified. They cannot be, which is great because it's going to save us a huge step of changing this thing into a mixed number, which is not required. It didn't say that we had to on this worksheet. So I'm just going to label it. Bam, inches, 185 sixths inches. Now again, for those of you that were like, man, I just need the mixed number so bad, here it is. Let's see, that'd be 30 and 5/6 inches if you want the mixed number. Now I said I'd do this twice, so here we go. Now the way that I'm going to do this is slightly different than the way that we did those last ones, okay, from the last lesson. And the reason I'm doing this a little different is because I know that 1/2 is less than 2/3. I need this first fraction to be bigger than the second one. So how do I do that? Well, I'm going to need to borrow from the 32, which means I'm going to make it 31. But instead of being that 1/2, I just added 2 units to it to make it 3 halves. See how nice that's going to be when we do this subtraction with method 2? Because now I got 31 minus 1, which is 30. And I have 3 halves minus, well, I guess I should have changed those into mixed numbers, or to the same denominators first. Dang it. Alright, that's okay, no worries. I'm going to go back to 3 halves minus 2/3, right? I need those common denominators. So we're going to make them 6 again. So I got 3 times 3 over 3 times 2. And then 2 times 2 over 3 times 2. So this would end up being 9 sixths minus 4 sixths, which again shows us the same answer as 5 sixths. So 30 and 5 sixths, which is again is the same answer as the mixed number that we had in the beginning. Don't forget to label this. I'm not going to worry about it because I did write the answer right there in inches. It's the same answer. So be careful of that. See how I almost made that mistake? I just kind of jumped to my 3 halves minus 2/3. The numbers are pretty close to being the same. It's just the denominators are not the same. So we need those denominators to be the same before we start subtracting fractions like that. Alright, here's our next example. If a piano student practices the piano 3/4 of an hour in the morning and 1/3 of an hour in the evening, how long did she practice that day? So there's 2 times that this student is practicing, right? First is in the morning, and then also in the evening, and that would constitute the whole day. And this is happening, the practice is happening 2 separate times. So how long did she practice in the morning? She practiced 3/4 of an hour. How about in the evening? That was 1/3 of an hour. Now we want to know how long she practiced total in the day, which means we're going to add these two together. Now we notice that the denominators are not the same. We need them to be the same, and whichever method we like, we should get the lowest common denominator either way. I'm going to use 12ths. So I know that I'd have to take 4 and multiply it by 3 here, so I'd have to take the numerator 3 times 3 there, which would be 9/12. And over on this side, I've got 4 times 3 again, which is 12, and then 4 times 1 there, which is going to be 4. 4/12. And we are adding these two together. 9 plus 4 is going to be 13, so it'd be 13/12. Now that's great. This looks good. 13/12. We did a lot of work. We kind of diagrammed or planned it out. It's just don't forget your labels. And the label for this one, both of these were in hours, so she practiced for 13/12 hours. Again, for those that want the mixed number, 1 and 1/12 hours. Both of these would work. That one was nice. No mixed numbers on this one, I guess, except for the answer, which is okay. We should know how to do that by now very well. But either way that you like it, both of these work. Alright, let's find the perimeter of this rectangle. Well, if I want the perimeter, I need all the side lengths. And over here, that shows 2 1/8 foot. So that means the opposite side is also 2 1/8 foot as well. And so on the bottom part here, the base, that'd be 5 1/4 foot also. So what we have here is 2 1/8 plus 5 1/4, right? Now that would be half the perimeter. The perimeter is all the way around the shape. Wasn't a very good drawing, but it'll still work. So I got to add another 2 1/8 with another 5 1/4. Now this is interesting. This comes out really nice. I'm going to use both methods on this. What I mean by that is I'm going to change these into improper fractions first. Alright? Now, again, we don't need to change the answers into mixed numbers. We're going to see it anyways. And I've really only got to do these both once because these two are going to be the same exact improper fractions, right? So I got 2 times 8, which is 16, plus the 1. That'd be 17 eighths. 5 times 4 is 20, plus 1. That's going to be 21 fourths. So we got 17 eighths plus 21 fourths, plus another 17 eighths, plus another 21 fourths. Now we are adding these together. We need common denominators, and I've only got to change these two, which are the same. Just need to multiply them by 2 to get a common denominator of 8. And then be 42 eighths for both of them, because it's the same fraction. So right now I got 17 eighths plus 42 eighths plus 17 eighths plus 42 eighths. Everything is in eighths, which means I can just add those together. 17 plus 42 plus 17 plus 42. Again, this is in eighths. What would that be? 59, 118? So it's 118 eighths. And that was great, right? I mean, we rocked that thing. That was pretty quick. But what do we notice here at the end? We notice that this fraction can be simplified. It looks like it's at least divisible by... So 118 divided by 2, that's going to be 59. 8 divided by 2 is 4. And I don't see that that can be simplified. So we could label this right now. The parameter would be 59 fourths feet. And yes, I didn't forget my label. On the other hand, if we were to look at that, and if I were to use the second method, first thing I would want is common denominators with those fractions. I know I can add the whole numbers right now, but I'm just going to change these, alright? So I'm going to multiply these by 2. So I have a common denominator of 8, right? So I'd really have 5 and 2 eighths here and 5 and 2 eighths there. So now that I've completed that, I can look at all the whole values. 2 plus 5 plus 2 plus 5 is going to be 14. Then in the number of eighths, right, and I know I'm going to need to simplify that eventually, that's no problem. In eighths, would have 1, 2 more, 3, 4, 5, 6 of those eighths in. So we'd have 6 eighths right there, which we know is simplifiable. So I'm not going to label this yet because I know that my final answer is going to be, it's going to look a little different. It'll still be 14, alright, but the 16 and the 8 are both divisible by 2, which makes this 14 and 3/4 feet. So whether you use the mixed number or the improper fraction is not going to make a difference. You should get the same answer either way, though. Alright, this is on the next page. We got a freight truck that has 1/4 tons of computers, 1/3 ton of televisions, and 3/8 ton of small appliances. Find the total weight of its load. Alright, well, what do we got in the truck? So first of all, we got some computers, right? Then we got some televisions. And then we got some small appliances. Now, the weight of this is going to be added together because that will tell us the total weight of the load. And how much tons is there in computers? 1/4 of a ton. How many tons of TVs? 1/3 of a ton. And how many tons of small appliances? 3/8. And yes, we are adding these together to find the total. Now, we're going to find common denominators of these. However, whichever method you use to find them, you could use multiples, right? And you could say, well, I got 4, 8. Now, there's the 8. That's okay. But when I do the 3s, 3, 6, 9, I missed the 8. And I could use the 12. The 4 goes to 12. That's fine. But the 8 doesn't. It goes 8, 16. No good. So, 4, 8, 12, 16. 3 is going to miss 16. So I'd have to up that but by doing that, I'm going to miss the other 3, right? We got 3, 6, 9, 12, 15, 18, 21. Just barely missed it. So let's go on to 24. 24 looks good for 4. 8, 16, 24. So 24 is the common denominator that I'm looking for on this. So what do I multiply the 4 by to get 24? It looks like it is the 6th multiple of 4, which would make 1/4 now 6/4. 24 is the 8th multiple of 3, so I've got to multiply it by 3 and the 1, making that 8/24. And the 3rd multiple of 8 is 24, which now makes this fraction 9/24. And we are adding all these together, which is nice, because we got 6 plus 8 plus 9, which is going to be 23/24, and that's in tons. Well, I guess that's all we need for the label, actually. So this would be 23/4 tons of product or appliances, whatever you want to call these things. 24 tons. Alright, that takes us to the next problem. If Tucson's average annual rainfall is 11 3/4 inches, and Yuma's is 3 3/5 inches, how much more rain on average does Tucson get than Yuma? So it's asking how much more rain it gets, right? So again, we could diagram this out. If we look at Tucson first, see if I can spell this right. So Tucson, we'll say that it goes up, and it goes up, this is 11 3/4 inches. That's their annual rainfall. And then over here we'll look at Yuma, which isn't as much, right? So we'll start here in the bottom. And this one only takes in 3, maybe about right there, 3 3/5 inches of rainfall. Now the question is, how much more rain does Tucson get on average? Well, that would be this much more, right? This much more right here, which means that the Yuma amount is going to have to be taken off of the Tucson amount, which is going to tell us how big that purple bar is. So it should look like this: 11 3/4 minus the 3 3/5. That will tell us how much more Tucson gets than Yuma. Now, whichever method you use, it's not really going to make a big difference. I don't know. I'm going to use the second method on this, okay? Now, to do that, I am going to change the denominators to be the same. So instead of 11 3/4, I'm going to show this as 11 15/20. And then over here, I'm going to show this as, instead of 3 3/5, it is now going to be 3 12/20. Which again is going to make this. Alright, find the total length of the diagram. Now, one of the problems we get on this one is that some students are like, well, I got to find that length. No, we don't have to find that length. We're just looking at the total length from here to here, straight across on that. So I know some of you guys were like, dude, I'm going to do the Pythagorean theorem on this thing, and it's going to be great, and I'm going to love it. No need for trigonometry or angles on this one. We're just going to simply take all 3 of these values. Right, we have the 1/2 inch, the 11/16 inches, and the 9/32 inches, and we are simply adding these together. Now we should notice that we do not have common denominators at this point, but that 32 is going to be a fabulous common denominator to use. So the 9/32 is just going to stay as 9/32 on this one. I'm going to go to the 16 and 11/16 right here and change this into 30 seconds, right? The question is, what do I multiply 16 by to get 30 seconds? I'd have to multiply it by 2. So now that becomes 22 30 seconds, And I know what to multiply 2 by now to get 32 is 16. So I got to multiply the 1 by 16 as well to make this 16 30 seconds. We're just adding these suckers together, right? So in terms of 30 seconds, I got 16 plus 22 plus 9. We'll even do the work up here. Plus the 9er. Adding all these together, we get 17 47. So that's 47 30 seconds. Now I stopped to look and see if this can be simplified. 47 30 seconds cannot. Therefore, this is my final answer in inches. And of course, this would be the answer for those of you that just need the answer in mixed numbers. It'd be 1 and 15 30 seconds in inches. So either one of these would work. Alright, and that concludes the lesson for this one. We did all the problems on this worksheet. Hopefully it helped you guys out. If it did, that's awesome. Keep working hard. You guys are doing great. And we'll see you in the next video.